So this is a Venn diagram. So Venn is a person's name. So we use this Venn diagram to show the operations of sets. So the outside rectangle, so this rectangle we call universal set. Then the circle subsets of the universal set. So here we have N as a subset of U. We have Y as a subset of U. All right, so the question wants us to do the shaded region to represent the shaded region with the sets and the operations. But again, we have three operations. We uni, we have intersection, we have a complement. Use C, we use apostrophe. So now the shaded region, you see the shaded region including everything, just not Y. So obviously, that's a Y complement, or use Y apostrophe, right? So everything in the universal set, just not in Y. Now let's see B. We see this shaded region in the intersection of M and I, right? So first, we see it's in M intersect with I. But then it does not include this part, right? Only include this part. So what is this part? Regarding to G. So that's intersect. So first we put a parenthesis, M intersection with I, then intersect with G prime, G complement, or G prime. Or this we read G as prime or apostrophe. So M intersected with I, we get this red color. Then when we intersect with G complement, because everything else, let me use a different color. G complement is everything outside this G, right? Outside this G. So when we intersect this red and outside the blue, so get this shaded region. So that's M intersect with I, then intersect with G complement. Okay, let's erase this. Let's see next question. Oh, by the way, this is not from our textbook. I just Googled them. Now let's see this. So that's why notation is a little bit different. So we can, in our notation is S raised by C, S complement. So the Venn diagram, all right. So we want to represent S complement intersect with K. So let's first draw S complement. S complement including everything, just not inside S, right? That's not inside S, it's just outside of S. Intersect with K. Well, this is K. This is K. So what's the intersection part? Let's use red color. So everything, outside of this blue color, the intersect with K. The intersection with K, that's this part. Right, this red color, so that's this. That's this. S complement, the elements not in S intersect with K. Intersect with K. That's elements in here. Let's see B. T union M. So T is this set. Right. When a union M, so let's do this. So union the set M. So get this, right? The T union M. So this everything inside these red curves. Then complement of that. So everything else other than inside this, all this. Outside this, I should draw blue, right? Everything else outside, let me draw blue color also. This outside this T union M. This is the T union M. Inside the blue color. So outside the blue color is the complement of T union M. Okay, that's this one. Let's see this question. So use the diagram below to find the cardinality for each problem. Well, cardinality means how many members, how many elements in a set. So let's see. So this n parentheses just means the number of elements in n. Well, let's see n. N is this. Right. N is this circle. How many members there? 37 plus 4 plus 7 plus 13. So why the number is marked like this? Let's just do one by one. So these 37 elements are only in N. Only in. And these 4 elements only in the intersection of R and N. Right? So 4 represents in the intersection of R and N. And also this 7 also in the intersection of R and N, because the intersection is this. Intersection of R and N is this part, is red part. Right? So this 4 means only in the intersection of R and N. 7 is in the section of all 3. You see 7 is in R, 7 is in E, 7 is in N. So 7, this 7 means in the intersection of all 3. So how many in the intersection of R and N? 7 plus 4, which is 11. What about this 13? These 13 are only in the intersection of E and N. E and N. And how many in the intersection of E and N? It's 13 plus 7, which is 20. 20 in the intersection of E and N. Okay, so that's what this number means. Well, this 26 means only in R. This 41 only in E. Oh, now I have one more. How many in the intersection of R and E? 9 plus 7, right? 9 means only this 9 are only in the intersection of R and E. 7 in the intersection of all 3. Okay, that's what those numbers represent. Okay, now let's see the cardinality of n. So in n, let's just circle n. How many numbers we have? We have 37 only in n. Then 4 plus 7 plus 13 in the intersection with others. So add 7 with 13, we get 20. Add 37 with 4, we get 41. 41 plus 20, so we get 61 in total. So the cardinality of n, 61, means we have 61 elements in n. Now let's see B. Cardinality of R intersect with E, then union N. Well, let's find R intersect E. R intersect with E is this, like it's 9 plus 7, 16. But then union N, union N, union N. Right, so what do we have? We have 9 plus 7, union plus 4 plus 13 plus 37. We're not going to add 7 twice or 13 twice, right? It's only once. 9 plus 7 in the intersection of R and E. Union N, 7 is already in N, so we don't add any more because we already add in the intersection. Then we have 4, we have 13, we have 37. So we add all this. Add these two numbers, what do we get? We get 50. 13 plus 37, 50. This we get 7 plus 4, we get 11. 9 plus 11, we get 20. So 20 plus 50, so we get 70. The cardinality of this set is made of R intersected with E union N, has 70 elements. Now let's see C. Cardinality of E complement. Let me change my color. Green color is not so obvious. Let's change the red color. Okay, let's mark E complement. So this is inside this red circle, that's E. What is a complement? Its complement is everywhere else, right? Let's mark with blue color. So we have this 76, we have this 37, we have this 4, we have this 26. Right, those are not in E. So that's E complement. So we just add them. 76 plus 37 plus 26 plus 4. 76 plus 4, we get 80. 37 plus 26, 6 plus 7, 13. 13 plus 50, 63. So 143. 143. So cardinality of E complement is 143. All right, let's see. Oh, we have more. Okay, again, I don't like this E minus R thing. All right, let's forget about this because the plus minus is not in set notation operation. Let's see cardinality of U. Right, U means the universal set. So everybody, just add up all the numbers. Just add up all the numbers. So I have 76. Let's get here. 76, 76 plus 37. So we mark the ones we already add. Plus 4 plus 7 plus 11 plus 13 plus 41 plus 9 plus 26. Right, all the numbers. So let's look for easy numbers to add. 9 and 41, that give us 50. Then 11, 13, that give us 24. Then 24 plus 26. Then we have this number. 76 plus 37. So 113. These two numbers also give us 50. 50 plus 50, 100. 100 plus 113, so we get 213. So the cardinality of the universal set is 213. Okay, let's see F. Cardinality of R intersected with E intersected with N. So how many in the intersection of all three? 7. Right. So this 7 is in the intersection of all three. So that's just equals to 7. Okay, let's finish this. So this is a Venn diagram.